Good morning, good afternoon, good evening. This is Ocean Exchange 8 webcast series of the pandemic season. And my, what a season it has been. Thank you for joining us. I want to remind everyone that this session is recorded and there'll be a URL that you can socialize later, re-listen to, share with friends. I see a number of newcomers that are listed and registered with us, and we welcome you. I see a big group from our North American neighbors in Canada. Welcome to you guys. And I see a large group from a Florida maritime company, so and other names that I don't know yet. So I welcome all of you to make contact with me, and I will make contact with you. For the newcomers, I want to tell you about Ocean Exchange very quickly before we move into the program. We are a nonprofit and we have one mission, and that's to advance the adoption of innovative solutions that are all related to sustainability, but we do focus on oceans, coastal systems, and ocean shipping, particularly sustainable shipping, of course, and the decarbonization ultimately of ocean shipping. We have two guests today. They're both one's from Scandinavia, Western Europe, and we welcome them both. And I'm going to turn this over to Dane Dunstan. He is our MC in our physical event. Many of you know him from that. He does a great job. Dane, take it away.
Thank you, Millie. How nice. So this is a great webinar or webcast, and I'm really happy to be here because it really is close to something we've spent a lot of time working at this year in Reservoir, which is our consulting company. We've been spending a lot of time helping port clients and shipping clients think about how to think about emissions, primarily in the ports. You know, if you think about what's been happening, so much of the emissions in shipping is far enough offshore that it feels invisible. Yeah, the ports can be dirty and smoky, but most of us aren't sitting in ports, so we don't see it. But the shipping industry, if it was a country, would be the size of Germany, and its carbon footprint would be an enormous industrial global carbon footprint. And it's an industry that's really spent a lot of time over the years working on solving that problem, very interested in emissions control, how to get better at it. And as we know, not an easy thing to do in a big industrial setting. What's been happening, particularly with our clients in California, but it's global, is when you have a year like California's had this year, with the massive amounts of fire, learning new terms like fire tornado and flame cumulus clouds. Suddenly you start to think that goals of getting emissions down to zero in parts of the port by 2035, that may not be soon enough. We really may have to move a lot faster. And solving that has always been one of Ocean Exchange's mandates. And now I think one of the mandates is, how can we accelerate it? So today's speakers are working hard to address that. And I'm really excited to have them on. Sophie is just doing tremendous work with the SFC. They spend a lot of time helping companies all over the world think about how to get this better. And Bettina is an old friend from Ocean Exchange. She was a 2014 finalist, and we spent a lot of time talking. So really excited to have the two of you here today. And just want to get started, but before I do, a couple of things. We will be having a lot of questions, and if you're new to this, we have a lot of dialogue. Sophie and Bettina are going to interview. I'm going to interview both of them, and we'll take your questions. So if you have questions, don't put them in chat, if you wouldn't mind. Put them in the Q&A, and then I'll moderate those. I'll bring your questions in. If there are any questions that are very technical, what we'll do is wait till the session is over, and then we have a post session you're welcome to stay for, and we'll really get into the technical questions. So with that, Let me introduce Sophie. Sophie is, Sophie's the founder and executive director of the Smart Freight Center, and I'll let her explain what that is. But they coordinate global shipping industry players in how to think about and reduce their emissions. Doing great work. So Sophie, go ahead.
Yes, good morning or good afternoon, everybody, depending on where in the world you're based. This is from me, hello from Amsterdam. I want to explain the importance of logistics emissions disclosure. So Smart Freight Center is a global nonprofit organization. We're dedicated to zero emissions freight. And what makes us unique is that we cover all modes of freight, so sea, air, roads, rail, inland waterways, and logistics sites. And we cover all the solutions that need to be addressed. And we only cover freight, nothing else. But today I want to go a little bit more detail in a very important step, which is logistics emission disclosure. So why is it important? Next, please. It's very urgent. What we see now is that we have in 2015, almost 3 billion tons of CO2 was emitted to the air from freight transportation. And this comprises 8% of global emissions. And if you were to add to that all the emissions from logistics sites, such as ports, warehouses, distribution centers, airports, etc., you would get to closer to 11% of global emissions. On top of that, emissions are going to double at the current pace, so more than 6 billion tons. And you see road freight is the biggest culprit with 62% now. But if you look at ocean, you see that's the biggest grower, heading to a little over a third by 2050. So we need to do something to reverse that trend. Next, please. And there's 5 solutions that Professor Alan McKinnon, who wrote in his book Decarbonizing Logistics, has identified that combined can already reduce 80% by 2050. And if we know that that's possible based on information now, then obviously full decarbonization seems in sight. The 5 solutions are: first, you want to manage your freight demand growth. Is it really needed? So you could restructure your supply chain, for example, having localized sourcing of raw materials and manufacturing closer to where the customers are. You can optimize the use of transport modes, where you're looking at taking freight from air to road or from road to sea, and making sure long distance, for example, is done by rail rather than road. And as a result, again, reduce emissions. The third strategy is to making sure that your fleets and assets are used to the maximum capacity. So here we're trying to get fuller trucks, fuller ships, for example, by consolidating the loads from different customers. And in ocean freight, it's already happening a lot, but for trucking, there's a big area for improvement. But we can also see how we can have open transport networks, and that's called the physical internet. So how we can share assets between different users. Then we move on to improving the energy efficiency of fleets and assets. For road, you might think of better tires or eco-driving or aerodynamics. And for example, ships, you might look into slow steaming. And the final area is to use the lowest energy efficiency source feasible. So here we're talking about electric hybrid trucks, low emissions fuels for sea. And I even seen solar and wind powered ships already. So those are the 5 solutions, and we need a combination of them all. Next, please. So how can companies act? If you're a company, you really need to develop a roadmap, and we've called that the Sustainable Logistics Roadmap. That covers 4 steps. First is where are we now? So it's report credible emissions across the multimodal supply chain. The second one is to set targets for emission reductions that are science-based. And science-based is mean that you set your targets based on your contribution to staying below 1.5 degrees scenario under the Paris Agreement. The third is to reduce emissions by implementing solutions as a freight buyer. So you might, for example, as a buyer, work with your supplier to see how you can, say, for example, use renewable fuels, or as a supplier. And the fourth step is to collaborate, because this freight sector is so fragmented. You cannot do this alone. You need to collaborate with your suppliers, with stakeholders in society, and of course, make sure that there's also supportive policy to help you do that. Now, what Smart Freight Center does is we develop guidelines and tools, and some of the ones are here listed, that we either develop alone or we lead the development, and sometimes we contribute to the guidelines of others, such as the Science-Based Target Initiative. Next, please. The one I wanted to go deeper on is the GLAC framework. So this is about emissions calculation and reporting. We developed this framework first in 2016, and then an updated version came out in 2019. It's the only globally recognized methodology to calculate emissions across the multimodal logistics supply chain. It builds on existing methodologies. For example, for ocean emissions, we made use of the methodology developed under the Clean Cargo Initiative, whereas for road, we made use of both the SmartWay in the US as well as the European standard EN 16258. This methodology is recognized by the Greenhouse Gas Protocol, CDP, Science-Based Targets, and the UN. It is now the basis for a new ISO standard that will come out at the end of 2022. And so far, we are aware of 100 multinationals using it and 20 programs, tools, and missions incorporating it. But we suspect there's many more companies out there that are really already using the GLAC framework. Next, please. So here are some of the users, the companies that use it. And on the right, you see that what we also do is we check for several programs and tools, so such as Clean Cargo, an eco-transit tool, or Flexport, that they are able to calculate the emissions in accordance with the GLAC framework. That means that you as a company can make use of any of these programs or tools to calculate your emissions, and you know that they're consistent with the GLAC framework, and so you can add up apples to apples. Next, please. And the basis of the GLAC framework is that you cover all modes, so you don't just cover one mode, but all of them, including logistics sites. You cover your own emissions, which is scope 1. You cover emissions from electricity you use, which is scope 2. And you cover the emissions from outsourced logistics services, so from your suppliers, which is scope 3. You cover all greenhouse gases, so not only CO2, but any emissions that contribute to climate change. And that includes also black carbon. And finally, it's important to consider the full fuel life cycle. So not just the use or the burning of emissions of a fuel, but also the production and distribution of fuel. So you have your full fuel life cycle emissions. Next, please. And then once you've calculated emissions, you can use them for different purposes. So first, of course, you can set targets and track progress more confidently, contributing to the Paris Agreement goals, because you actually know what emissions you're generating, and you can then track how you're reducing them. Second, we found that many companies, once they map their emissions, they identify hotspots where they're saying, for example, only a couple of % of our freight is carried by air, but it might be a third of the total emissions profile. Or you might find that a railway or a transportation lane from China to Europe is way higher than, for example, within Europe. And then you know where could you best take action to reduce emissions. Third one is to improve sales and customer services, because of course, more customers are now asking to consider climate in their decision who to buy services from. And you can, as a customer, improve the procurement and supply management, because you can then actually ask your suppliers to provide their emissions that they generate for your services, so you can add them up. And finally, it is a matter of time before emissions reporting is going to be as scrutinized as financial reporting. I think any company needs to be ahead of the curve and manage their climate risks, and use this also to then advocate for supportive policies and programs. So this is in a nutshell why companies should measure emissions and reduce them, and the 4 steps to do it. Thank you. Back to you, Dane.
Thank you, Sophie. That was great. And I just want to ask you to hang out with us and stay with us. I'm going to bring you back in a few minutes, and we'll have a conversation with Bettina.
Thank you.
Let me introduce Bettina, and let me just refer to something that Sophie just said. In the Sustainable Logistics Roadmap, point number 1 is getting credible data about the emissions so we know what we're working with. And that's what Bettina Knudsen and her company Explicit are all about. They're a green tech company specializing in monitoring emissions. They've done some great science, and it's really fun, Bettina, to have you here, because I can see how far you've come in the 6 years since we were in Savannah together at Ocean Exchange. So Bettina, let me hand it off to you and tell us what you're doing.
Well, thanks a lot, Dane, and thank you for inviting me here. You're right. We did have some very interesting conversations in Savannah. I remember one of the questions you asked me was that if we, when we deployed our sniffer drones, could sit and drink coffee, you know, while the drone was out there doing its work. I'm happy to report that I've been sitting here north of Copenhagen all day drinking my coffee while the drone has been flying off of Calais this morning. Although there are pilots flying it, I have been able to, or we've been able to follow the data from Calais all day. So, so we're getting a good step ahead. Thank you for allowing me to speak here. What I'm going to try and talk a little bit about is how we monitor maritime emissions and the technology that we've developed to sort of build an infrastructure and how we can capture this data. Because you're right, Dane and Sophie, one of the main challenges in emissions monitoring is actually capturing the data. Next slide, please. So Explicit, we're a small company with a heart in emissions monitoring. Really, our mission is quite simple. We want to try and make a difference in how we monitor emissions. There are a lot of emissions out there today that we don't actually have good technology or techniques of how to monitor, and that also means that there's a lot we still don't know about their impacts and you know how they affect the world around us. Some of those emissions are harmful. What we do at Explicit is we try and help measure and document them so authorities and industry can take effective action. It's really about making informed decisions, both in terms of policy, in terms of enforcement, in terms of reduction strategies and what have you. We really have four components to what we do. The first is innovation in how we apply technology. So we work with microsensor technology, we work with drones, we work with aircraft, whatever we can get our sensors on to trace and sample emissions in real scenarios. The second step is we work in linking data, you know, from the field to the experts and onwards to the clients who need them when they need them, so that they can take action on the results. And the third step, and this is really important for us as well, is we work very hard to try and enhance the value of that data through quality assurance protocols and validations, transparency on the methodologies and all of that. It's important that we work to preserve data integrity around this, and that's a real important point for us. And fourthly, we try and offer expertise and our knowledge and our data, you know, wherever we can in advising and trying to help, you know, decision makers make informed decisions and report on what we find. Next slide, please. So when we talk about emissions, what we focus on is mostly what I call the usual suspects. So that would be sulfur and CO2, it's NOx, it's methane, potentially black carbon. It's sort of the components that we most talk about and that we have, I would say, the most urgent need of monitoring. Now, the second thing that we focus on is the measurement scenarios where traditional means are usually either impossible or they're unfeasible today. And there are actually a lot of those cases out there. Now, we have two legs to stand on, you might say. One is maritime emissions, which has been our sort of our first area of focus. But as of recently, we've also started looking at land-based emissions. Obviously, we'll focus on the maritime side today. Next slide, please. So in terms of maritime emissions, what we're really talking about is we're talking about regulatory enforcement, or at least that's where we're starting out. And Explicit has really helped to try and pioneer the field of how we do that. If you imagine vessels that are sailing out at sea, as Dane rightly said, often we don't think about their emissions. That's because they're so far away, we can't even see them in some cases. And so how do you enforce emissions regulations on something that's difficult to access? This is where we've tried to develop methodologies and concepts and technology that allows authorities to monitor these regulations, more specifically MARPOL Annex 6 regulations, which is the section of the International Maritime Organization sort of guidebook on regulating maritime emissions. There are four components to our solution. The first one is smart flight. Smart Flight deals with software on how to guide the pilots, whether it be a drone pilot or it could be a, a helicopter pilot, in navigating the exhaust plumes from a vessel. We're dealing with targets that move and a very dynamic environment where the wind and what have you is influencing our target emissions. And so we're having to deal with navigation as the first point. We've developed some tools to do that and to assist the pilots. Now, the second point is the instrumentation in itself. What we work with are small, lightweight sensor instruments, microsensors, state-of-the-art microsensors that can fit into small boxes. I might be able to show you on the video later what they look like. And the benefit of that is really, it's easy to scale the technology. We can put it on almost any drone or helicopter that is available. It's not we're not restricted by the instrumentation. It allows us to get out into the plumes and do our readings. The third step, as I talked about, is the data side, and that's really important from my point of view, because this is all about data at the end of the day, good data. What we do is we connect the information we collect in the field to a centralized emissions lab, where we have analysts that run through the data, that check for quality and run all those protocols before. At the end of the day, we issue emissions reports to the authorities, that they can then take action on. And that's the fourth step, is sort of the reporting of the results. We have some online tools that we have available to our authority clients where they can see maps and statistics, run their compliance analysis, and sort of get an overview of that data set. And really, there is even a fifth step, because at least here in Europe, our systems are linked into port state control systems as well. So whenever we catch a violation, that violation creates an alert in the port state inspector system as well, that allows port state inspectors that then decide on whether they want to fuel sample the vessel. So that integration of data is important as well, because it really speeds up the action that you can take. Next slide, please. So what does it look like? Well, this is what it looks like. As of today, we have inspected almost 3,000 vessels. I think we might actually reach 3,000 vessels by the end of this year. So that's quite a substantial data set. What you see here on the left-hand side is the drone we're currently flying, the one I mentioned off of Calais. Then this is what it looks like. It's a big drone, 150 kilos. As you can see, it has a little gray box on the side of it with a black arm out. That's actually our sensors inside, and our air inlet on the side of the drone as well. We don't pilot this, as I said. We have our instrumentation on it, and we process the data for it, but we have partners we work with on behalf of the European Maritime Safety Agency, who then run the whole pilot operation involved in this. We also have our sensors on manned helicopters as well. There are certain areas, for the nature of the seas, basically, where that's an option to use, and then we'll put exactly the same instrumentation on manned helicopters and go out and do exactly the same thing. But we've also had it on small drones as well. We've flown it in port, we've flown it out far, we've basically been anywhere at sea that you can imagine. And so this is one of the great advantages of working with this kind of technology, is that you can really implement it in a lot of different platforms in a lot of different contexts. Next slide, please. So what have we learned so far? And we've been doing this, collecting this data for about 6 years now. And these are some of the observations, and going back into what Sophie was talking about as well, about what's really important here and where are we in terms of the regulations. So when you talk about maritime emissions, there are certain of these pollutants that are regulated today, and some of them are not. On the sulfur, which most people have heard about, I'm happy to report that at least what we see is that the sulfur regulation is working. Ever since there has been restrictions on the permitted level of sulfur in the fuel, either in the special environmental zones called ECAS or the global cap, we've seen a reduction in overall SO2 in the atmosphere, and more importantly, we've seen less violation in those areas where there actually is a lot of surveillance and enforcement, which is my area in Northern Europe. So that regulation, that's the good news, appears to really be working well. Now, the next regulation is on NOx, and there is regulation on NOx. That's the good news. The bad news is that regulation isn't particularly good when you talk about real sailing emissions, what actually happens out at sea. The way it works is that ships are tested, the engines are tested before the ships are put out to sea, and that really, and certified, and that really is your stamp of approval that all is good on NOx. Now, unfortunately, what our data is showing is that might not be entirely true. And this is one of the areas where we have some concern. Now, there's another thing that I think people need to be aware of when you talk about NOx is it's sort of a negative side effect of CO2 reduction. So as we all try to go green, you know, and lower CO2, you might actually have a negative effect on the NOx side. Then we talk about methane. Methane is all the attention today. We're seeing an increase in the use of liquid natural gas as a fuel. We're seeing an exponential increase in LNG ship, and that should all be fine because that's supposed to lower our CO2. But the problem is that some of these vessels can have a slip of methane to the atmosphere, and methane is a much more potent greenhouse gas than CO2. So that is a potential concern. And as I said, as it says here, some bad engines actually have some slip. So that's an area to definitely have a focus on. We started measuring methane for the first time this summer as some the sensors became available to us. And this is an area where we definitely feel there's a need for more attention. And regulation. Methane is currently not regulated under the IMO MARPOL 6. Then there's black carbon. Sophie mentioned black carbon as well, which is these ultra-fine particle dust components that travel far in the air and cause, among others, the Arctic to melt and have a number of other, severe effects. Black carbon is really difficult to measure, particularly in the micro sort of very smallest size of it, the ones that can travel the furthest. The good news is that the sulfur regulation does seem to have a little bit of a spillover effect on the black carbon side, but the real question is whether it's enough or whether we actually need further regulation on black carbon. So those are some of the observations that we've made through now, having measured more than almost 3,000 vessels on these various areas, and where we see that there is still a great need either for regulation and certainly for more knowledge, because this is perhaps, to get back to what you were saying, Nain, there's still a lot we need to learn about maritime emissions. We don't know everything yet. Thank you. Last slide.
Thanks, Bettina. And here's how to get in touch with Bettina if you'd like to. We've got some interest. Let's get Sophie back in. And a couple of questions that we've got are coming in. If you put your questions in the Q&A section, we'll get them in a second. But Sophie, why don't you kick off? What do we need to know about what Bettina's doing?
Yeah, of course, it's very interesting to hear your story. Yeah, it's getting dark in Europe.
Yes,
and my first question is maybe a little bit technical, but I suppose one on everybody's mind. How do you do the sampling of the plumes? Well, how does that work? Can you briefly explain that?
Yes, so the sampling is actually sort of pretty simple. One of the things that help us is that what we're actually measuring is we're measuring the ratio between SO2 and CO2 in the exhaust plume, right? And that ratio is constant throughout the plume. So one of the benefits we have is we're not dependent on a specific distance to the stack. Right? I mean, just as long as we get within range of the plume, so our sensors can get a nice gas signal, then we're fine, right? So it's not a game of precise distance, which is a good thing. Now, the second thing, as I said, is the navigation. This is absolutely crucial because contrary to popular belief, plumes are usually not visible, not even if they contain a lot of pollutants. And so pilots really don't have a way of navigating them, except what we do is we allow them to navigate on the gas signals themselves. So they're literally sniffing their way, to find the correct positions in the plume. So, so those are some of the
sniffer drones. You have sniffer drones instead of.
You have sniffer drones, and they're flying noses, literally flying noses. So that's really how we do it. And then I say the last step is we also measure background, because obviously we have a lot of CO2 in the background that we need to account for.
Yeah, and then coming on that CO2 issue, because of course, ideally, anyone trying to address climate change would like to address climate change and air pollution at the same time. So it's a little bit worrying when you say, if you're investing in fuel efficiency and thus reducing the CO2, you're going to get an increase in NOx. Can you explain a little bit why that is, and if it's like a massive increase? So are you essentially saying don't reduce CO2, or what's your message here?
No, I guess what my message is that is as you're trying to reduce your CO2, and usually the way you do this traditionally is you try to improve your fuel efficiency. This is what ship owners do as well. They try and increase the mileage basically they get on their fuel, and that will reduce your CO2, and that's fine. The problem is that as you try to improve your CO2, you have an adverse effect of an increase in NOx. This was basically what brought us Dieselgate, right? Yeah. I mean, that as they were trying to make the diesel cars, run further on the mile, they had an adverse, problem with the NOx emissions. Yeah. And marine engines are the same. Now you can address that through catalytic, reduction, and there are systems to do that. The problem is they're not mandated for only for a fraction of vessels out there in the fleet. So most of the vessels don't have these systems on board. So as the ship owners push for more efficient vessels, and that makes sense from a business point of view if you're a ship owner, you will reduce your CO2, but you will likely also increase your NOx. And that's really the concern. And the bigger the vessel, the bigger the problem. So
what I'm basically hearing from you then is, as you improve fuel efficiency, there needs to be parallel legislation to address the slightly increasing NOx payment, in this case
yes.
through SCR. But
yes.
Do you have the same with LNG? Because the LNG is becoming very popular. There's a surplus of LNG, it's being pushed on the sector, understandably, also for economic reasons. So companies seem to like it. But then at the same time, you hear studies, for example, by the International Council of Clean Transportation, that there's the issue of methane slip. For those in the audience who've known about LNG, can you give us a rundown of why is it being used? What are the benefits and the challenges with it? With using LNG for ships?
Well, LNG, on the pro side, the world has plenty of it. So as you say, that makes it an attractive choice. And it's supposedly a greener alternative, right? I mean, if you run on an LNG basis, you might save something like 20% of your CO2. So it's attractive, and you have no NOx. So it's, it's attractive from that point of view. The problem you have, and this is partly what our recent data is showing, this is the real concern, is that some of the engines allow, some of that methane to slip through the burn process and be released as gaseous emissions into the air. And why is methane a problem? Well, methane is a problem because, as I said, it's a much more potent climate gas than CO2. Some say 30%, 30 times more, sorry, not 30%, 30 times more potent than CO2. That's actually, if you look at a 100-year lifespan. If you look shorter, 10 years, Dane was talking about how we need to do action now. Methane is like 100 times worse than CO2. In terms of its greenhouse gas effect. So even, a little slip or some slip, through those engines can actually cause you to have, a negative, net negative, climate impact. Because if you convert that methane to CO2 equivalents, so you're trying to, again, apples and apples, you were trying to save on your CO2, but you ended up putting something in the air that was much worse. That's the concern, right?
So are you suggesting here again, because you're saying there's certain engines, and I assume that's like the cheaper versions of engines that have bigger methane slip. Is then the solution to try and make sure that we tighten in parallel the regulations on the quality of engines that come into the market to make sure that the methane slip is minimized, if not eliminated, in order to to offset that risk? Or what would be the solution? Or do you say LNG is not the future?
I don't think you ban LNG as such. I mean, it's a good choice, and for good engines, and we see that in our data as well. We've collected, some real sailing data on that as well. And the good engines don't have this issue, but there are some engines that do. I think this is a clear case of where we have a deficit of regulation, and we need to act fast, because also for the sake of the industry. I mean, ship owners are having to make really, really hard decisions right now on which fuels to go for and which technologies to go for. And we're not helping them if we're holding up regulation, like on methane.
Very good. So when it comes back to the carbon accounting, for greenhouse gas accounting, for those who are looking at that, you then need to look at the production of LNG, because of course, liquefied natural gas means there's energy going into to make it a liquid, then the combustion, and then the slippage. And that combination gives you the total greenhouse gas footprint. And if you use better engines, which tend to be more expensive, but at least then you're upfront thinking about that methane slippage and preventing it. And government policy, then you say, that starts moving those engines in the direction of those better quality engines might be a helpful step in that direction. I'm looking at Dane. I see he's always aware of the time, but I have one last question for you, Bettina. I'm very curious to hear. It's nearly Christmas, and if you could have one wish from Santa Claus, what would you now say? Where do you see your technology go? How can it go? Have you reached a ceiling? Do you see other potential applications that might help the broader industry to reduce both pollution as well as CO2 emissions?
Well, if I only have one wish, I would say I definitely see more potential in the port side. Ports are under, as Dane was saying, tremendous pressure these days to reduce their emissions, to work with it. There's a lot they can do on the land side to do that, but at some point they're going to have to negotiate and sort of get into that dialogue with the vessels about their emissions behavior. And in that, you're going to need individual ship monitoring of some sort, because right now, emissions from ships in port is one big black cloud. It's difficult to distinguish between the super emitters and the ones that you don't have to worry about. That's what you can do with using a tool like sniffer drones, and try and sort of create a more nuanced picture. Yeah.
And could the ports then also use this perhaps to start rewarding those ships that are polluting less, for example, by reduced port fees? I mean, that's already happening, I believe, in some parts of the world. So
there are some ports. Yeah, there are some ports that have tried this, and that would be the natural step, to try and think this into green incentive schemes, how you can work with real emissions data, right, to award those who do well and punish those who may not do as well, or however you want to do it. I mean, it doesn't necessarily just have to be the fees, it's just also how the port organizes itself, right, in terms of that emission footprint, right, fast-tracked options and what have you. It's not necessarily just monetary.
Yeah, and then thank you. And before handing back, I want to add one comment. If there's any customers or freight shippers in the audience, I think really procurement is a big potential here. And initiatives like Clean Cargo for ocean and various green freight programs for land freight are really looking at that, right? To see what can the customer do to direct the carriers in the right direction. And I think by having full disclosure of emissions, perhaps not only CO2, but broader air pollutants, would really help in driving that collaboration between the customers, the freight buyers, or the customers and the ship owners and carriers to together reduce this. And I think your technology can be a major step forward in tracking individual ship level emissions, which is where I think ultimately this needs to go to. Yes. Fantastic.
Yeah, indeed.
Absolutely.
Back to you, Dane.
And thanks, Sophie. That's great. And stay with us, because we may have some other questions. We've got some from the audience, but I just want to jump in on what you guys were just talking about. It's really hard in the ports. A lot of investment is being put into dockside power, so we can just plug the ports into shoreside power, plug the ships in. In Los Angeles this year, in the middle of the summer, the drain on the electric grid was so huge that they had to ask everybody to unplug the ships. So now the ships in port had to run on their auxiliary engines, which is not what anybody wanted. So it's a bigger thing that goes over the whole question. Let me go to some questions from audience members. I was speaking of ports. From Elisa Preskovich wants to know, Bettina, what's your capacity for service in the U.S., both coastwise and in ports?
Well, I have the good news is, I guess, is I don't know, limitless, because we haven't really started our operations in the US. It's one of the things that we're hoping to focus more on. So any invitation to try and do something on the US side, I would welcome. The downside is that there actually isn't any of this being done on the US side, to my knowledge, at least right now. All the activity in terms of airborne surveillance has been done on the European side. So there's still great potential. To do stuff on the US side.
So here's a question from Peter Sutton. How much does environmental factors, wind, rain, fog, how does that affect test results? And he wants to get specific about how does it affect results when you're comparing a baseline test to maybe a second test after they put on scrubbers, or you want to check out, if they've made some improvements?
So in terms of the impact of precipitation on the results, I think the thing that has the greatest impact is really weather, or any weather or slug or things like that, for the simple reason that it washes out the CO2 from the atmosphere. This is essentially what's known as acid rain. So in conditions of very rainy conditions, you typically wouldn't attempt to measure, because you can't entirely rely on it. You might underestimate the sulfur. Now, in terms of the scrubbers, what we see very clearly is that you can clearly distinguish between what when the scrubber is on and when the scrubber is not on. The good news on the scrubber side is actually that a lot of the scrubbers we're seeing come to market and being put into operations perform better than what the regulation required them to do. So they're supposed to remove sulfur to the 0.1 level, or 0.5 out of the outside the ecozones. Many of them actually can perform and deliver much lower than that, almost to the point where we can't even measure it. I mean, so that's the really good news on the sulfur side. I hope that answered the question.
I think so. And just by the way, while you were answering that, Ann Carpenter, who's on the board of Ocean Exchange and is with Braid Theory in Los Angeles, popped up to just let you know that they may have an opportunity out there for you. So I think she's going to be in touch with you.
That's good. Good to know.
Elizabeth Peterson wants to know about your funding history. Are you actively fundraising?
We have so far relied entirely on soft funding. Explicit is 100% management owned by me and my husband. So it's a family-run business. It's been a conscious choice so far to take it to this step. Not that we're excluding the possibility for further funding as such, but as we have moved through our own phases of development, we've sort of been lucky enough to be able to rely on soft funding. So far we don't have any third parties involved right now, but we're keeping our options open. It's interesting.
Yeah, but if I may add, I think for you it will be really important to get advocacy, right? To spread the word about this technology and how it might be applied, because I think what I'm observing is there's a lot of technology suppliers out there like yourself with really good testing results and applications, but very often policymakers are not aware of it, or port operators or other companies or programs, right? And as a result, there might be a mismatch between the two. One that I would like to add to that one, and there's also a question about, is LNG a transition fuel, which I saw late somewhere else, is there's the Getting to Zero coalition, which was initiated by the Global Maritime Forum, which is another NGO, our friends, also based in Denmark. And they set it up with the Friends of the Ocean and the World Economic Forum. And their aim is to, by 2030, only have zero emission ships enter the market, similar to what the UK announced today. From 2030, no more diesel or petrol fueled cars, so we really go in that direction. With that type of policy and that type of commitments, it is a transition fuel. But at the same time, I think 1 ton of CO2 or emissions reduced today is 10 tons in 2030, because you're talking about 10 years between now and then. So I'm so keen to see very quick action now, what we can now to reduce emissions as soon as we can, but never allow that to be an excuse to delay the ultimate game, which is zero emission ships, zero emissions trucks, zero emissions planes. Yeah, so I do think we need both solutions, but we need them yeah, we need we need to do now in order to get to zero emissions in a couple of
Yes.
years' time.
Yeah, and I think from our point of view, this is where you say, in order to guide that process and make, the most informed choices about how we get to that goal, ultimate goal, you're gonna have to measure more on the real sailing emissions and real life in order to really understand what's going on. I mean, take biofuels, for instance, right now, which is also being discussed and tried and tested by a lot of ship owners these days. It's a good option for many, but reality is we actually don't know exactly what's going on in those emissions. Most biofuels are waste products, and we don't have a complete picture of what's actually in those emissions. So we don't know if we're creating other problems, right, as we're trying to solve the sulfur and the CO2. So this is where really the emphasis is on the need for emissions monitoring, actually measuring in those emissions to understand what we're putting in the air.
So we've got one, this goes in right into a question that we've got. It'll be our last question. And then there's another question that's pretty interesting, but I'm going to hold it till after we finish. Then we can have an after session for anybody who wants to stay around because it's really a business model question. So here's the question from Francis Weld. Can your sensors determine the types of fuel or fuel mixes from which the emissions originate?
The answer is no. We don't know specifically what's in the tanks. What we measure are the gases, so the gas footprint of whatever is being put through the engines at the end of the day. And as I said, we have the normal sort of SO2, NOx, CO2 components, methane, components that we look at. But the sorry, I'm just gonna have to. I'm sitting in an office with a light sensor. That is very lazy. The answer to that is that's really difficult to understand exactly what the emissions is. But at the end of the day, that might also not really be important, because what does it ends up in the same components in the air, right? And that's really what you have to focus on. And this is part of the problem that we have also on the regulatory side right now. We're focusing on the fluids and not the air, right? On industry, land-based industry, the regulation is focusing on the air and not the fluids. And that's part of the challenge here, right? In the way the regulation has been set up. But again, at the end of the day, it's the same components. It's your sulfur, it's your CO2, it's your NOx, it's your, whatever other components you want to look at from a gas perspective.
Well, cool. Well, thank you, Sophie and Bettina, so much. If you'll hang around, we've got a really interesting question from Nicholas DeGolia that we'll come to in the after session. It's a business model question. Millie, I'm handing back to you.
Millie is on mute.
Okay, Alice, you can roll our final slides, please. I want to thank Dane, and we can't thank him enough. And he is a volunteer to us. I have to recognize that, and we're very grateful for that. He talked a little bit about reservoir, and you can catch him online if you want to talk to him later. Next slide. We do have our final webcast of the year scheduled. It is December 16th, 11 o'clock in the East in the US, 5 p.m. Central European time, 8 a.m. Pacific, and we'll focus on CO2 sequestration. So it's related to this, but very different in fact. So watch our social media. If you have not signed on to our newsletter, there's a link to do that. There's a link at the bottom of each of my emails. If you have an email from me, you can subscribe there as well. Next slide. I want to recognize our sponsors. Wallenius Wilhelmsen in Norway is our largest sponsor. Gulfstream has been with us since day one, and you see the other major sponsors here. You can see all of our sponsors on oceanexchange.org. Next slide. And here's more contact information. The webcast library link is also on the homepage of our webpage, homepage, oceanexchange.org. And I'll turn it back over to Dane and anyone who wants to hang around for a little bit more chat. And if we get into something very, very detailed, I'll even unmute you as an audience member if you want to talk directly to Bettina or Sophie. Thank you so much.
Thanks, Millie. So Nicholas asked a really interesting question that really caught my ear, because Reservoir right now is involved in a project in California where we're looking at a very, very expensive acceleration of getting emissions down in the ports. And who pays for that? A lot of the technology is not ready quite. It's not like, so it's got to get some investment into it. And the question from Nicholas is, how can cargo customers, these are the people who own the cargo that's in the containers or in the hull of the ship, how can they work with carriers to encourage them to increase the level of transparency in their emissions reporting at the vessel level?
I guess that's a question for you, Sophie, first.
Yeah, I was gonna give it a try. So the question specifically about emissions reporting. Well, one, I think it's really important that cargo owners use the same methodology. And so the GLAC framework covers all modes of freight, but when you then go deeper into ocean, there's the clean cargo methodology for container shipping, and there's now the Sea Cargo Charter for bulk shipping. And so you have, and they're linked to programs or initiatives. So that means that shippers come together with carriers in the same program. So Clean Cargo has done this in 2004 to work out together what methodology are we going to use. And they can also be a mediator to help the exchange of data between them. And it means that the carriers spend less time having to calculate emissions for different customers, because they can do that collectively through one platform. And shippers also have to spend less time because they can rely on platforms who already have done the checks to make sure the consistent methodology is used. And on the back of that, once you have more transparent communication about the emissions, and I think the next step for Clean Cargo and various other initiatives is to get down to that level deeper, you know, at the ship level, then our freight lane level, they need to go a little bit more granular. Then you can work out together what are the solutions to reduce emissions, both CO2 and air pollution. And while doing that, you can understand what are the costs involved. And so one example that I know several customers or shippers are now looking at is giving carriers longer contracts. If you, let's take road freight as an example, if you need to change your trucks to electric for urban settings, it takes a couple of years to pay them back. How are you ever going to dare to make an investment if your customers are best giving you a 1-year contract? You need to think as a shipper, if you're truly committed to climate change mitigation and your targets, you have to also give more flexibility and certainty to those carriers to do that. The other way is to do joint pilots, and I'm aware that both through Clean Cargo, but also through the World Economic Forum, now that it's getting to Zero Coalition, they're looking at, can we set up joint pilots between both shippers and carriers to test things, whether it's alternative fuels, whether it's investment in zero emission ships. Because even though those technologies sometimes are still a little bit on the horizon and not quite there yet, testing together makes it also more likely that the burden, both financially as well as resources and risk management, is also going to be shared. And the final example I want to give is procurement practices. So BSR through Clean Cargo has developed a sustainable freight procurement framework, which gives four levels of maturity for procurement. And Smart Freight Center with the World Business Council have developed guidelines with concrete examples of how shippers through their contracts can put this to practice, and a model questionnaire, a questionnaire template. What questions should you be asking your carriers? And again, if we get alignment, harmonization, it takes less time for the carriers to have to deal with so many customers, and it takes less time for the shippers or the customers to put it in practice because somebody has already thought it through for them. So here's where NGOs like ourselves come into play to make it easier for everyone to happen.
That's great. So Roger Strevens has a question. How do you see longer contracts working in liner shipping where there are cargoes of multiple shippers on every sailing? How do you achieve alignment and critical mass?
This is interesting. I think, and he's saying asking for a friend. That's nice. I think what's going to be key, and this is again where BSR and Smart Freight Center are looking at together. In the end, we need one market signal, and that is we want green freight. We want freight that for which the footprint is known, not just greenhouse gas, but air pollution, whereby the carriers have set targets, whereby they have a plan to reduce them, and where we promise as freight buyers to collaborate. And the moment you got that pledge or that charter in place, then it becomes easy, because then the shippers must collaborate in order to make that happen. So I think it starts with that common market signal that is shared. What happens right now, I see still too much, is that individual shippers set targets and make commitments, but because they're not unified in their message, in practice, they start doing still a little bit in isolation, and that makes it very difficult for carriers to respond to or deal with multiple customers in parallel.
That's a great question. There's one other question, but I think we covered it. It's about the LNG footprint. So unless anybody else has any questions, do you have any more questions, Sophie, for Bettina? Because I have one.
Well, yeah, well, I just want, because we talked a little bit about, about Europe, Horizon Europe, which is the big funding, like billions of euros going into there for the next years. For NGOs that are on the line, or NGOs like myself and others, there's Global Maritime Forum, Smart Fleet Center, BSR, others. How can we help you to get your technology, to raise awareness on it, to make sure that your technology gets included in research programs? What help do you need concretely from organizations like us?
Well, I mean, and this is actually getting back to the funding side, because right now we have a deficit of funding in terms of, maritime emissions research. And this is one of the burning platforms that I'm having to deal with. I'm sitting here with an awful lot of NOx data, for instance, and I'm having trouble, offloading or sort of getting attention around to really do more of that. There is a great need for more funding in this research, and the point I really want to make in terms of what we're doing is that, so what Explicit has done, we've essentially created an infrastructure that allows us to capture this knowledge, right? We do, fleet-wide analysis. When we measure hundreds of vessels, in campaigns and things like that. There really isn't anybody else that can do that. And that's the key component that's missing. But there's been a lot of those studies, then they use one engine or two engines or one ship here and one ship there. What our technology and our infrastructure allows us to do is map out big areas, right? Big fleets samples instead. And that's just a whole different ball game in terms of what you can learn. So we would very much like to team up with NGOs in terms of the research side. We are helping projects already today, both projects that are looking to test sensors, but also projects that are looking to learn more about maritime emissions. And that's really what we want to try and do. The more we can try and shed a light both on the broader sort of fleet patterns, emission patterns, but also on the individual profiles, the better. I mean, that's the way we can contribute and create some value here, I think, for the world. Again, it's all about, making it possible for policy and industry to make informed choices, right?
Exactly. And you're sitting on a incredible amount of data that could inform that. But it's like, what you're almost saying is NGOs like us could be the connector between you and researchers, between the policymakers. But it's very useful, because now I finally understand what you do and how it works. So,
well, Bettina, I think Ann Carpenter and I will accept the challenge to try to find some parties in the U.S. to do this.
That would be fun. We would love it.
I want to wrap with the final comment from Roger Strevens, because it goes back to the one market signal unifying shippers. It's a really, really great point. He says, how about developing the signal from consumers? Their customer, the shipper's customers, will respond to consumers. Because if I want to go out and buy a Nissan Leaf and get my car to be zero emissions, then I would like to know that it's coming over on a ship that reflects that and reflects my desires. I think a lot of people would report that. So listen, that's all the time we've got. Thank you very much, everybody. And Millie, any last words?
No, thank you both. This was terrific. I can't wait till we have the URL. We'll send it to you, socialize it, put it on all your platforms, and we will too. Thanks again.
Thanks,
everybody. Happy Thanksgiving to our US attendees.
Yes, and nice to have strengthened the Europe-US link through this event.
Yes.
Thank you very much for that opportunity. Especially thanks to Ann Carpenter for that. Thanks.
Thanks. Bye-bye.
Bye-bye.
Bye.